Hello, my name is Eric. We're going to do a quick video today on how to graph a certain style of linear equation. This is probably the easiest kind, and it's called the slope-intercept equation. It has a form, and if the equation you're trying to graph doesn't look like this exactly, then you cannot use the ideas that I'm going to present here today. The form looks like this. There should be a number here for M and a number here for B, but there will always be a Y and an X. Those are variables. Now, when you want to graph one of these things, make sure you have this form. Make sure Y is isolated on the left side of the equal sign, and make sure that on the right side, the X appears multiplied by something, and then there's an additional number added or subtracted. And I'm going to explain to you what these things are now and how to use them. Let's start with the easiest one, B. Okay, this is the y-intercept. That's the official name for it. You could also call it a starting value. As long as you remember that your graph is always going to start on this line right here, which is called the y-axis. So this other number that multiplies x is called the slope. And it generally tells you something about your line, whether the line increases or whether the line decreases, whether it goes uphill or downhill. But it also tells you how steep the line is. So I'm going to illustrate this with about 3 or 4 examples, and then I'll show you some nuances where we probably won't go all the way through with the graphing. To save time, we'll probably just talk about how to make the problem presented to you look like this form. All right, let's go for it. Here's an example. Y equals 1/2 x plus 3. Start with the y-intercept. Start with the y-intercept, and remember, everything on the y line has x equal to 0. Here's the point 0, 1. Here's the point 0, 4. Here's the point 0, -2. They all start with 0. If you put 0 right here for x and multiply by 1/2, you get 0. Add it to 3, and you'll find out that when x is 0, y is 3. And so, you get this point, 0, 3. That's the x, that's the y. And it's called the y-intercept. Really easy to find. Go to the origin, and when that 3 is a plus or a positive, go up. 1, 2, 3 spaces, or jumps, or units. We're halfway done. The next thing to do is analyze this, the slope. Now, people have different ways of explaining this. I've taught this subject for almost 30 years. I like my kids to do things right, and I like clarity and simplicity, and here's a really simple way to graph, or to remember what to do about slope. A, make sure it looks like a fraction. If it doesn't, we'll need to compel it to look like a fraction. B, make sure the number on the bottom is positive. If it's positive, then you can trust that it will always, always, always mean to go to the right. In this case, go 2 units to the right. The number on the top, you've got the option of up or down. The number on the top means go up if it itself is positive. That's pretty clear, isn't it? So we're going to go 2 right, and then 1 up, and we're going to do it from this y-intercept, or this starting point. 2 right, 1 up, 2 right, 1 up, 2 right. When you run out of space, if you want more points, you can reverse both of these things and go 2 left, 1 down. 2 left, 1 down, 2 left, 1 down, 2 left, 1 down, etc. I'm not going to take the time today, but you should then connect these points using a straight edge to show that, for example, numbers that are not exactly on the grid point. For example, this is 3 to the right and 1, 2, 3, 4.5 units up. That's a point on the line too, as are all of these points in here. So you really need to draw a nice straight line through here using a meter stick or a yardstick or something like that. That was pretty easy, wasn't it? You want to have another example? Well, I don't blame you. Okay, this one's almost the same, but this time, example 2 looks like this. 2/3 x minus 1. The starting point, the y-intercept, is not 0, 1. Why not? Because that minus sign belongs to the 1 and makes it a negative 1. Does that make a difference? Yeah, you're not going to start here. That's 0, 1. You're going to start here at 0, negative 1. And then as far as the slope goes, what did I say before? That's the slope. The number on the bottom needs to be positive, and it always means go to the right. The number upstairs in the numerator, when it's positive, it means go up. So this is just like the last example, and we're going to go 3 right, 2 up. From here, not from the origin, but from this y-intercept. 3 right, 2 up, 3 right, 2 up. If you run out of room, go 3 left, 2 down. And yeah, I'm going a little fast here, but I don't want this video to go on for, 75 minutes or something ridiculous. Both the examples that you have seen so far are lines that are increasing. That is, going from left to right, the line looks like it goes up the hill. And it does. What's happening is that as x's get bigger, y's get bigger also. But that's not always the case. Let's take a look at example 3 here. This one says y equals negative 2/5 x plus 1. Where does it start? On the y-axis, at the y-intercept, which comes from here. That's found right here. What's the slope? Negative 2/5. What do those numbers mean? Well, you can count on this. The number on the bottom is always positive, and it always means go to the right. I don't like to use words like rise and run and things like that, because to me they're just a little bit ambiguous, and what we don't need is ambiguity in our instruction. Our kids need to know. I think every kid I know remembers that going right is that way, okay? Now the number on the top means up about half the time, it means down about half the time. How do you know which is which? Well, the previous 2 examples didn't have a negative on them. They both meant go 2 up. This one with a minus on it means go 2 down. Pretty easy. From the y-intercept, go 5 to the right, and then go 2 down. We're already out of space. We can't go out here and do that again. I wouldn't know how to find that. But I can do the opposite of both these things, and I can go 5 to the left, and then go 2 up. What's important is, anytime the slope is negative, you should see a line that decreases from left to right. Goes downhill. The idea is here that as the x's get bigger, the y's get smaller. And then, of course, get a meter stick out and trace a nice straight line through here, which I'm not going to bother to do today, but I will mention it. A third example looks like this. You know where it starts, don't you? It starts at 0, 2. And you know that that's on the y-axis because, well, it's called the y-intercept. Any point that begins with 0 is found on the y-axis. What about the slope, though? Last time we had a negative 2/5. This time we have 1/4 with a negative sign out in front. Okay? Do yourself a favor and move that negative sign to the top. Don't put it on the bottom. Don't put negative on both of these. Move it to the top. And then, everything I've said in this video holds true. The number on the bottom is always positive, and it always means go to the right. The number on the top, when it's negative, means go down. Pretty clear. 4 to the right, 1 down. starting from the y-intercept. 4 to the right, 1 down. Well, I'm not sure what that is, so I'm going to also go 4 to the left and 1 up, and then trace a nice straight line through here. I think that's about it for graphing, but I do want to show you a bunch of examples of things that don't immediately look like a slope-intercept equation, that with just a little bit of manipulation, you can force them into this form. So for example, what if I give you y equals 2x plus 7? The slope-intercept form looks like that. I think we're good, right? But what about the 2? We've been dealing with fractions there. What do you do when there's not a fraction? The answer is, well, over here, start at 0, 7. That's way up there. But for the slope, if they didn't give you a fraction, you go ahead and divide by 1. I think we all know 2 divided by 1 is still 2, and so I've changed the way this thing looks. It's got different cosmetics, but it's got the same value. And now you can do what I told you before. The number on the bottom is positive and it always means right. So 1 right, 2 up. What do you do when there's no number here for slope at all? A missing m, but you do have an x. Well, then you take the liberty of multiplying by 1. So you write this out as 1x minus 5. And the y-intercept is, don't forget that negative goes with the 5. The minus goes with the 5. And then, like we did in the previous problem, the slope is going to be 1. And since it doesn't look like a fraction, we're going to divide it by 1. So what will this mean? It will mean 1 right, and it will also mean 1 up. And again, I'm not going to draw these because you've seen enough examples of that, I believe. So that's a missing slope. What do you do when there's a missing y-intercept? Like this. And I don't show you anything over here. Well, that's not too bad. Just remember that in life, when you add 0 or subtract 0 from a number, you don't change its value. You know, if you have $8 and then you don't earn any new money, you still have $8. 8 plus 0 is 8. So in this case, what you do is you just write 2x plus 0. And now you've got slope-intercept form. So this thing is actually going to start at 0, 0. And it's going to have a slope of 2 divided by 1. It's going to go 1 to the right and 2 up. Which one of these do you deal with first? Oh, you always do this one first. Always. Okay, here's an example. Maybe we'll actually go graph this one because I haven't graphed anything in a couple minutes. So, is it clear where to start this problem? Yeah, the y-intercept is 0, 3, and that's found right here. Is it clear what the slope is? Not at all. But when you don't have a number here, you can always multiply by 1. So the slope is 1. Well, no, not quite so fast. There was a minus sign here. And it's going to belong to that 1. And then to make this look like a fraction, you're going to divide by 1. The number on the bottom is always positive. It always means go to the right. The number on the top, this time because it's negative, it means go down. So from the starting place, you're going to go 1 right, 1 down. 1 right, 1 down, 1 right, 1 down. And just keep the line going like that. I think we've located it pretty well. 2 other quick examples. You get a problem like this. Y equals 2. And you're asked to graph it. Okay. I'm not sure common sense is your friend here, because too many students I see will go to y equals 2, and then they'll remember that the y-axis is vertical, so then they'll go to 2, and they'll draw a vertical line. Good try, but that's not really the way it goes. So there's 2 ways to explain this. I'll show you my favorite. Imagine that you had a table full of x, y values that you were asked to plot. And the x's can be anything you want. But the y's must, in every case, be 2, like constantly, okay? Where are those going to be? Well, 1, 2 is right here. 2, 2 is right here. 3, 2 is right here. 4, 2 is right here. You get the pattern? We have a horizontal line that does not increase and does not decrease. As a matter of fact, we say it has a slope of 0, and it looks like this. No slope, 0 slope. As a matter of fact, I've seen this explained, and it's not a bad way to do it, as this is 0x plus 2 with a slope of 0. Of course, for that, you just have to know that a slope of 0 is horizontal. Excuse me. One more. Last one. How do you graph something like this? Well, this has basically nothing to do with slope-intercept equations, but it comes up often enough that I would like you to know how to handle this. So a good way to conceptualize this is make a table of x, y values. You're going to be asked to plot these. Here's the rule. Y can be anything you want, but x's have to be 3's. Always, constantly. Where are you going to find these? 3, 1 is here. 3, 2 is here. 3, 3 is here. 3, you can see what's going on. We're getting a vertical line where all the points are 3 units to the right, which is exactly what these are telling you here. That's kind of a slow way to do it. I've got a better way to do both of these, as long as you can remember the steps. How do you graph y equals 2? I'll tell you how I do it. I go on the y line to 2, and I draw a line that's perpendicular to the y-axis. How do I draw x equals 5? I go on the x-axis, over here 5, and I draw a line that's perpendicular to the x-axis. Perpendicular, you mean right angles, right? Yeah, that's what I mean. Well, I think I've covered this pretty well, although I must admit, I didn't really have a lesson plan or a script, and so, but I do think I've gone on far too long. Again, my name's Eric. I hope you learned a lot from this. If there's something I didn't cover and you have a question about it, stick it in the comments below, and I'll do my best to answer your questions. Thanks a lot, and have a good afternoon.